Okay, this is our outline. So if you look at your GPS that I just gave you, like right here, right? Okay. The vocab's on the back. Okay, what do you notice? There's only 2 learning targets. Right? It's going to be a smaller test, it's going to be a smaller unit. It's going to take us about 4 or 5 class periods to get through this material. I have included the notes. It's already up on Fusion. I put it up this morning. All the notes are there. So all the days of notes that I'm going to do, I've already kind of figured out what I'm going to talk about. I've already tweaked it. I'm probably going to tweak it some more, but at least it's all there. I've put a bunch of these videos in to help explain it better. So if you think that I'm crazy and whacked and I'm not doing a good job explaining it, look at the videos. They might help. So learning target 1, we're going to talk about the origin theories. So that's nebular hypothesis, Big Bang theory. We're going to talk about that today. And then we're going to talk about different things. We're going to talk about stellar evolution. Yay! Yay! That's actually really exciting. This is where we get to talk about black holes and supernova and cool stuff. We're going to talk about HR diagrams. HR diagrams is just how do we kind of characterize or organize stars on a graph. And then we'll talk about galaxies, and then we're going to be done. It's going to be real quick. Jarnell, what's your question, man?
I feel dumb asking this question.
Don't feel dumb.
This black hole we're talking about, right? Is it the black hole that the parents say stuff on doing
a black hole is the result. I'm going to give you a preview. You get a star that's super, super, super big. It's like at least 3 times bigger than our sun. More likely 7 or 8 times bigger than our sun as far as mass goes. And it gets old, or it runs out of fuel. Now thankfully when you guys drive your car and you run out of fuel, the car doesn't explode. Yeah. That actually is what happens in a sun. So if the sun's big enough, it runs out of fuel, it explodes, and if the explosion is big enough, ladies,
well, die.
If the explosion is big enough, well, nobody's around when these things happen because life as we know it's only on Earth. When these explosions happen, the star is completely obliterated, and what's left over is so heavy that not even light can escape from it. So a black hole is technically a star in space that's so heavy no light escapes.
So it's not black.
So you're saying like this gravity is real strong?
Yeah, its gravity is like crazy strong. Crazy strong. Crazy strong that it holds in light, which is mind-boggling if you start thinking about it. But we will start thinking about that in the next few days. Okay? I'll take us more from here. Okay, just a refresher, there's 2 learning targets that we're going to be doing today. Now, do you guys, I don't know if you get confused by this. I don't want you to be confused by this. If you look up and it says 23.1, the solar system, that is referencing the book, chapter, and section for which this slide comes from. So I don't really understand solar nebula theory. Well, you can go to the online book, chapter 23.1, and it talks in detail about this. So if you're not understanding me, that might be a way for you to go back and understand it a little bit. Solar nebula theory, well, it's actually pretty simple to understand if you're not doing the math. Okay, this is something you could be doing in an AP physics class, but we're not going to get into that depth. There's just so much really cool math here. Alright, solar nebula theory. Alright, you got your notes out? Okay, first you're going to draw this. This is a giant cloud of gas. A nebula passed gas. That's what passed gas. Alright, this is a giant cloud of gas. It's gas and dust. It's made up of different elements. It's usually mostly made up of hydrogen and helium. Okay? Hydrogen and helium. So what is the first thing we're going to draw? Yeah, a nebula. N-E-B-U-L-A. Here. I'll label these as we go. Here we go. Here's a nebula. Nebula. Alright, nebula. Okay, giant ball of gas. Now when I say giant, like it makes our sun look like a speck of dust. in the ocean. Okay, it is huge. They span hundreds and maybe even thousands of light years, if not bigger. Some of the nebulas that are out there. Okay. Nebulas contain mostly hydrogen and helium, but they also contain some cool stuff like dust and rocks and iron and all these other elements. Remember how we watched that video and how when you have these supernova explosions, it creates all these different elements? There's a smattering of those elements in the nebula. That's good for us, and we'll see that in a minute. Okay, well, dust and dirt and iron and nickel and cobalt and gold and titanium and carbon, and it's all there. It's all there. But that's just a small percentage of what's there. Okay, well, nebulas, well, when stuff is in space, everything has gravity. That gravity likes to get people together for parties. Okay? So if I'm standing next to Stephanie and I are here. I have gravity, she has gravity, we're floating in space. Eventually our gravity pulls us together. Now we have between us a little bit more gravity, and then Aaron and Mark get pulled in, and the table. Okay, now we have even more gravity, and Salik gets attracted by our gravity, and we're pulled into this group. And then we start getting bigger and bigger and bigger. Do you guys see this process? This is called accretion. Okay, accretion. Okay, now, what do we notice here? Here we have a giant ball of gas. Is it as giant here? What do we notice, Mark? It's starting to flatten. Interesting. Interesting. So, the word I'm going to give you is collapse. Collapse. C-O-L-L-A-P-S-E. So, if the building's roof collapses, it falls in on the rest of the building, and now everything got a little bit more tight. Okay? This nebula is collapsing. Now, this is kind of fun. When nebulas are out there, they spin. They rotate. Very, very slowly. But when they start to collapse, that rotating speed stays constant, but now it's smaller. So now it's just going faster and faster and faster. So what you need to know is it collapses and spins fast. Starting to collapse and spin. What shape is it starting to make? Think of this not as a circle. Think of this as a three-dimensional object. A disc. A disc. It starts to spin fast in a disc. Okay? So we have a nebula, big thing in space. It starts to collapse. It starts to spin. And the smaller it gets, the faster it spins. And the smaller it gets, the more flat the disc gets. Okay, so what happens as it gets smaller? The disc becomes... Okay, let's all say that so I know that you all heard me. What happens to the disc the faster it spins? It becomes flatter. Anyone here like to ride bicycles? Okay, bicycles. Do you know how if you take a tire or a bicycle and you push it until the bicycle slows down, it'll actually stay upright for a little bit? Okay, if you take a bicycle wheel and spin it, it will actually stay in a flat plane. That's that disc, as it's spinning, will actually stay in that nice disc shape. Kind of cool. Physics. Take physics, it'll be awesome. Okay. And then we get down to here, and now we have, what do I call this? I'm going to call this a proto as meaning pre-coming, like if I want a preview, I want to see it before everyone else views it, I want to preview it. Or if I preview a video before you guys watch it, I watch it before you watch it, I preview it. Proto kind of means a similar thing. It means primary, before. So it's a proto-sun or a proto-planetary. Oh wait, planetary, what does that sound like? Planets. Planetary disk. Okay, so you should have this drawn in your notes, okay, because this process is solar nebula theory, and it's actually very, very simple to understand on a basic level. It goes from really big and gassy and expanded, it starts to collapse, and as it starts to collapse, it starts to spin, it gets really faster and really faster, it gets really flat, and before you know it, a lot of the mass of the nebula is now concentrated in the space where a sun is going to form. Has the sun formed yet? No, it's proto-sun. It's protoplanets. Eventually it gets hot enough that what process starts to take place at the very core of the sun? Fusion. Fusion. So here we have fusion starts, planets form. Okay, this is solar nebula theory.